Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will go through everything you need to know for the upcoming test. So the test is based around congruence. So let's first go through what congruence actually is. So let's say I have a shape like this on your screen. So obviously that's a triangle. So if I flip this shape, I get something that looks like this. I get another triangle. Now this second triangle has the same size, shape, it has the same angles and same side lengths as the original. It's just in a different orientation. It's just facing a different way. It's positioned differently. So when that happens, we say that the two shapes here are congruent. So congruent essentially means that the two shapes are the same. So on your screen, it goes through exactly what congruent means. So these two triangles on your screen are congruent. As I said, they're basically the same. Same side length, same angles, same area. They're just positioned differently. So the bottom triangle is just a reflection of the top. So whenever you take a shape and you reflect, translate, or rotate it, you end up with a congruent shape. So congruence essentially means, if two shapes are congruent, that one can be placed perfectly on top of the other. So if we look at the shape on the bottom, if I reflect it again, I get something like this, and I can place that perfectly on top of the other. That's why they are congruent. So I can take this shape, as I showed before, I can reflect the shape, which means flip it. I can translate the shape, which means you slide it, move it over. I can also rotate the shape, which means that I turn the shape. So if I translate, reflect, or rotate the shape, the new shape is congruent to the original. They are exactly the same shape. So if I label my original shape O for original, note that I can actually perform a reflection or a rotation to get this shape down the bottom. So how do I know which I have performed? Well, I need to make sure I label the vertices. So I'll label the vertices here A, B, and C of this triangle. So that's how we refer to this original triangle. It's triangle ABC. So whether or not I rotate or reflect it, the A will end up down here. So I call this A dash. That means the image of A. That's where A's gone to. Now, if I reflect the shape, the vertices will be reflected, and if I rotate the shape, the vertices will be rotated. So if I rotate the shape, turn it, then C will end up here and B will end up there. So that's if I rotate the shape, if I turn it. However, if I reflect the shape, the vertices will be reflected. So then B will go here and C will go here. So note, B and C were swapped around depending on whether I performed a rotation or reflection. So if I leave the vertices as they are here, I can tell that this was a reflection. It would actually be a reflection about the line that goes through here, okay? So you need to know what translations, reflections, and rotations actually are. I need to be able to give you a shape that's been reflected, rotated, or translated, and you tell me which transformation, which of those three has been performed. And you also need to know that if I take a shape and I reflect, rotate, or translate, the image, the new shape, is congruent to the original. And that means that the two shapes being congruent, they have the same side length, same area, same angles, they are the same shape. It means that if they're congruent, one shape can be placed perfectly on top of the other. So let's go through quickly some shapes that are congruent that are not triangles. So congruence doesn't only exist for triangles. Any shapes, no matter how many sides they have, can be congruent. So I've got a shape here. It's a quadrilateral. It doesn't matter at this point whether it's a rectangle, parallelogram, or whatever. If I flip that, if I translate that, or if I rotate that shape, then each of the resulting shapes I get are congruent to the original. So all four of these, I'll just move this one so it's easier to see, all four of these shapes are congruent. Same side lengths, same angles, same area, same everything. So two shapes don't have to be triangles in order to be congruent. So why is it that we focus so much on triangles? The reason that we focus so much on triangles is they're a little easier to work with. So I said before that two shapes are congruent if all their angles are equal, pairs of corresponding angles are equal, and pairs of corresponding sides are equal. In other words, they have the same set of angles and the same set of side lengths. So what makes triangles easier to work with is that when I'm looking at two triangles to see whether or not they're congruent, I don't need to check every pair of angles and every pair of sides. I can use one of 4 tests to show that two triangles are congruent. So the tests for congruence are SSS, SAS, AAS, and RHS. So you use any of these 4 tests to determine whether or not two triangles are congruent. So in all of these, S stands for a pair of sides that are equal, A, a pair of angles that are equal. The R and the H are a special case. So the R means that both triangles are right angled. So they both have a right angle. And H stands for hypotenuse, which is the longest side of a right angled triangle. So you can only use the RHS test when both triangles are right angled. So what are these tests saying? Well, what they're saying is rather than checking every pair of sides and every pair of angles, we use one of these tests to determine whether triangles are congruent. So it's saying that if I have 1, 2, 3 pairs of equal sides here, so note, if they have the same number of dashes, they're equal. So these two sides with 1 dash here, they're equal. The two sides with 2 dashes are equal. That's what they mean. So what the SSS test is saying is that if I have two triangles like this and there are 3 pairs of equal sides, then those two triangles must be congruent. I don't actually need to then test the angles. I know that they'll be equal. I know corresponding angles here. These two will be equal. This one and this one will be equal. And this one will be equal, okay? So I don't actually need to test the angles if I know that all 3 sides are equal. So that's what the SSS test is. So let's look at these two triangles. So if I tell you that I have 2 pairs of equal sides, so those two are equal, these two are equal, 2 pairs of equal sides and the angle in between, then those two triangles will be congruent. This is the SAS test. So these two triangles in red are congruent by the SAS test. So this one's a little tricky. It can't just be 2 pairs of sides in any angle. It's 2 pairs of sides and the angle in between. So if you have 2 pairs of equal sides and the angle in between them is equal, those two triangles are congruent. I don't need to look at the other pair of sides, nor do I have to look at pairs of other angles like those two. They will be equal, the triangles will be congruent. So the next test is the AAA test. So that means two pairs of equal angles and one pair of equal sides. So this is easier than the SAS test because in the AAA test, it actually doesn't matter which pair of angles you have and which pair of sides. In SAS, it had to be the angle in between. In the AAS test, it doesn't matter which angle it is, okay? So these two triangles in black, they are congruent by the AAS test. Again, I don't need to test other sides that aren't marked as equal. I don't need to first test whether this side and this side are equal. If I have two triangles with two pairs of equal angles and one pair of equal sides, they will be congruent. Remember what that means? One of them is just a reflection, translation, or rotation of the other. It also means they have the same side length, same angles, and everything. So let's look at the last test. So the last test, RHS, as I said, you can only use that in right-angled triangles. So this longer side of the right-angled triangle, the one facing the right angle, is called the hypotenuse. That's what the H means. So these two triangles, they both have a right angle. So that's the R. The hypotenuses are equal. That's the H. And we have another pair of equal sides. So these two are congruent by the RHS test. So note one of them is just the same as the other but flipped over. So they are the four tests. If you want to tell whether or not two triangles are congruent, then you need to use one of these four tests. So let's look at lining up corresponding sides and angles. So let's say I have these two triangles here. So firstly, we need to decide, are they congruent? Well, they have two pairs of equal sides, and the angle between them is equal. So these two triangles are equal by the SAS test. So how do you write that they are equal? You write a congruent statement. So the first triangle, you can call whatever you want, so I'll call it triangle ABC. The symbol for congruence is like an equal sign with an extra line. So triangle ABC is congruent to, now when I'm writing the second one, I have to line up the vertices. So because I wrote A first, in the second triangle, I need to write the vertex that corresponds to A. So an easier way to try and line up the vertices is look at what information you have. So see, A here is touching the 12 centimeter side, but not the 10 centimeter side. So in the other triangle, it will be the one that is touching the 12 centimeter side, but not the 10 centimeter side. So A corresponds to E. So because I wrote A first, I must write E first. So which one does B correspond? So B is touching the 10 centimeter line, but not the 12 centimeter line. So B will correspond to D. And then C will correspond to F. So it's important that you line up the vertices. So now that we know that they're congruent, let's find X and Y. Well, that's not going to be too hard because I know that A corresponds to vertex E. So these two angles will be equal. So this angle here, that is called angle DEF. It's at E, so E must go in the middle. So angle DEF is going to be 65 degrees. Why is that? The angle sum of any triangle is 180. So 30 plus 85 is 115. I need 65 more to make 180. So that means X will also be 65 degrees because corresponding angles in congruent triangles are equal. So similarly, Y. So Y is at vertex B. Y corresponds to the one at vertex D, this one here. So Y must be 85 degrees. How easy is that? Now, also note that because the two triangles are congruent, this side here and this side here would be equal. So if this side here was, say, 7 centimeters, this side here would be 7 centimeters. So you can use congruent triangles to find unknown angles and unknown sides in the other triangle. So that's because corresponding sides of congruent triangles are equal, corresponding angles of congruent triangles are equal. Let's look at these two triangles on your screen. Are they congruent? Well, AB, which is this side here, is parallel to DE. That's what these little arrows mean, that they're parallel. So that means that this angle and this angle must be equal. So that's because they're alternate. So this angle here is angle BAC. A goes in the middle because that's where the angle is. And that's equal to this one, which is angle CED. E goes in the middle because that's where it is. And the reason is that those two angles are alternate. So also this angle here and this angle here would be equal to each other. So angle ACB is equal to angle DCE, and that's because those two angles are vertically opposite. So that's why we did a review of angles, alternate angles, vertically opposite angles, and all that. Sometimes they're needed to show that two triangles are congruent. Note all of the tests involved at least one pair of sides being equal. So these two angles so far, that's not enough to prove they're congruent. I need something about the pair of sides. So this side here, BC, and this side here are equal, and we're just told that. So I can write BC, which is this side here, is equal to CD, and that's just given. That's just told to us. So note, I have three reasons now. I have angle, angle, and a side. So these two triangles are congruent by the AAA test. So to write the statement, triangle ABC is congruent to, so A, this angle here and this angle here are equal. So A corresponds to E, B corresponds to D, and C corresponds to itself. And the reason, the test I used was AAS. So these two triangles are congruent. So that means pairs of corresponding sides and angles are equal. So if AB was 8 centimeters, then DE would be 8 centimeters. If, say, this angle here was 36 degrees, this angle down here would be 36 degrees. Again, I can use congruent triangles to find unknown sides and angles. So make sure you know all of the 4 tests. Make sure you know, when given 2 congruent triangles, how to decide which test you should use. All right, the last thing we're going to go through is properties of quadrilaterals using congruent triangles. So congruent triangles can be used to establish the properties of quadrilaterals. So quadrilaterals are just 4-sided shapes, and you need to know the definitions of them. So let's say I have a parallelogram. So this is what a parallelogram looks like. So I'm just going to give it as A, B, C, and D. So a parallelogram has 2 pairs of parallel sides. That's what distinguishes it from other types of parallelograms. So what I can do here is I can divide this into 2 triangles. So will those 2 triangles be congruent? Well, turns out here, if I draw AC, AC is in both triangles. So that means it's equal in both triangles. So that is a side in each triangle that's equal. So because of parallel lines, this angle here and this angle here must be equal. They are alternate. So this angle here I call BAC. This angle here is angle ACD. So why are they equal again? They're just alternate. I'll just put alt. So it turns out that because we have another pair of parallel sides, that this angle here and this angle here are equal. So this one is angle BCA. C goes in the middle because that's where the angle is. And that's equal to this angle here, which I'll call CAD. Again, they're alternate. So what I've just shown you is I've explained that there's a pair of equal sides, two pairs of equal angles. These two triangles are congruent by the AAS test. So the first triangle, I'll call triangle ABC again. So that's congruent to triangle. Now this is where it gets a bit tricky. So in the first triangle, which is this triangle here, see this angle is equal to that. So A in the first one corresponds to C in the second one. B corresponds to D, and C in the first triangle corresponds to A in the second triangle. Reason AAS. So I've just proved to you, I've shown you why the two triangles are congruent. So because they're congruent, that means that this angle and this angle are equal. So what we've actually done is we've shown that because you can divide a parallelogram into two congruent triangles, these two angles are equal. So this shows you that opposite angles of a parallelogram are equal. Because the two triangles are congruent, this side here and this side here must be equal because they're corresponding sides of a congruent triangle. Similarly, this side here and this side here are equal. So congruent, and the reason they're equal is because they're corresponding sides of a congruent triangle. So congruent triangles have allowed us to show that opposite sides in a parallelogram are equal. So we've shown using parallelograms that opposite angles in a parallelogram are equal and opposite sides in a parallelogram are equal. So congruent triangles can be used to show things that are true about quadrilaterals. And we can also use this trick to show things about rhombuses, rectangles, or whatever. So let's look at this shape here. So this is a kite. So hopefully you know the definition of a kite, that adjacent sides are equal. So these two will be equal and these two will be equal. So I can divide this into two congruent triangles. So why are they congruent? They have one pair, two pairs of equal sides, and then this is in both triangles. So these two triangles in the kite will be congruent by the Sss test. So because they're congruent, that means this angle and this angle will be equal. Why is that? Because they're corresponding angles of a congruent triangle. So we've just used congruent triangles to show a property of kites, that they have a pair of equal angles. So in kites, where the two unequal sides, this one and this one, meet each other, those two angles are equal on both sides. So congruent triangles can be used to find some very useful properties in quadrilaterals. Alright, sorry for the long video. I know that there is a lot there, but best of luck studying. You're a superstar. You're going to ace the test, and I'm always here to help you. Hope you have a great day. This has been the luckiest maths teacher in the world.